Hey guys, this is probability and statistics. We're starting with set theory. So let's say you and your friend are rolling some dice. Now if I asked you what outcomes are possible, what would you say? And if you said the numbers 1 through 6, then you're correct, and we can call this the sample space or the set S. We can say 2 is an element of S. So you end up rolling a 1, 2, 3, and your friend rolls a 3, 4, 5. And we can call this set A and set B. Your other friend agrees to roll 2, but only once, so they get a 6. And then we can call this the set C. We can refer to these sets as the events of this experiment. Note that since A and B have multiple outcomes, we can call that a compound event, and C only has one, and we can call that a simple event. Now for a couple rules about sets, there can't be any duplicates. So let's say you rolled 4 times and you got a 3 twice. You wouldn't put it in the set twice, you would just put it once. And the second is that it's unordered. So given this set of 1, 2, and 3, and another set of 2, 1, 3, give a second and think about if they're equal or not. And if you guess that they were, then you're correct. Now for some set algebra, keeping the rules in mind, if I asked you what the union of the set A and B is, which we denote with the symbol that looks like a U, what would you say this set is? Now if you answered with 1 through 5, then you're correct because you kept in mind that there can't be any duplicates, even though that A and B both have a 3. Now if I asked you what the intersection of A and B was, which we denote with the upside down union sign, what would you say it was? And if you guessed that it was just 3, then you're correct. Another operation is the complement of a set, and that's every single element that's in the sample space, but not in that set. So in this case, if I asked you what the complement of the set A is, what would you say? And if you told me 4, 5, and 6, then you're correct. Now let me ask you this. If we took the complement of the sample space, what would be our resulting set? And if you said that the resulting set was empty, then you're correct, and we can denote this with the empty set symbol, which is just a 0 with a slash through it. Now for some set relations, a subset of another set is a smaller set that has every single element that it has, and it could also be the same set. So in this case, A is a subset of S, and A is also a subset of itself. To be more specific, we also have proper subsets, which are the same thing, except they can't equal each other. So in this case, A is still a proper subset of the sample space S, however, it's not a proper subset of itself. Now for some laws that pertain to set algebra, we have the law of commutativity. As you can see, that if you switch the A and B, whether you do union or intersection, it's still the same set. So if I gave you these two sets, would you say that they were equal? And if you said yes, then you're correct. Here we have the associative law between 3 sets, and see that we can place the parentheses anywhere since they're being used on the same set operation. So if you were given this expression, how would you place parentheses to make this true? If you placed it around set F and G, then you're correct. Now take the expressions from the associative law and switch the signs. The distributive law tells us how to deal with this situation. So if I gave you this expression on the top, how would you make it equal by placing operators and parentheses? And if this is how you placed it, then you're correct. Here we have De Morgan's law, my personal favorite, which shows us how to deal with complements of resulting sets. A bit trickier now, but if I gave you this expression, how would you use De Morgan's law to solve this? And if this is what you got for your result, then you're correct. And if you don't understand it, take some time to work it through. Now for visual representations, we can use Venn diagrams. So give yourself a second and place where you think the outcomes of each event would go. If this is how you place each outcome, then you're correct. Here are some sets that you should know. Here we have the set of all natural numbers, which goes from 1, 2, 3, and so on. Here we have the set of all real numbers, which includes any number that you can possibly think of. Here we also have the set of all integers, which includes all negative numbers, positive numbers, and 0. And just know that since there are an infinite number of numbers, there are an infinite number of sets. See that a line can be represented as a set of points. Your family could be a set of people that are related to each other. Now that we've covered the basics of set theory, think about this for a second. If probability is represented as a function of p, why would we have the probability of the set A be greater than or equal to 0 and the probability of the sample space be equal to 1?